Hello, this is Irene Chapara and we will be working today on a polynomial. What we want to do is to find the formula, the rule of the polynomial, given the graph. So we focus on the graph first of all, and the first thing that we want to do is to find what are the points where the curve crosses the x-axis. These are going to be the x-intercepts for our polynomial. We can see right here for the given polynomial, the curve crosses the x-axis at three different points. These are going to be the x-intercepts. So the x-intercepts of the polynomial are negative 3, 0, negative 2, 0, and 1, 0. Another information that we have is that the polynomial, the curve, also crosses the y-axis at negative 1. So the y-intercept for this polynomial is 0, negative 1. We focus first of all at the x-intercepts. Since these are the numbers that make the curve cross the x-axis, this means that these are the x-intercepts that have a corresponding y-intercept equal to 0. So, simply, this means that these are the solutions for the polynomial. So, from now on, we will call these numbers the zeros of the polynomial. So, the number negative 3, negative 2, and 1 are the zeros of the polynomial. We want to make a table. And first of all, what we will do is write down the zeros of that polynomial. Negative 3, negative 2, and 1. At the next step, we want to consider that a polynomial, if it is factored, then it's going to have several linear factors. Now, assume that you have a polynomial and this is a linear factor of that polynomial. So, if this is a linear factor, then this means that the polynomial, the entire polynomial will be 0 when this factor is 0. So, this means that if the x is equal to negative 4, then this is going to be a 0 for the polynomial. This relation goes backwards as well. So, if negative 4 is a 0 for a polynomial, then x plus 4 is a factor of that polynomial. Based on this information, we can set up now all the factors of this polynomial. And we need to enter this in our table. So for negative 3, 0, negative 3, the corresponding factor will be x plus 3. For negative 2, it's going to be x plus 2. While for 1, the corresponding factor will be x minus 1. So now we have the factors of the polynomial. We can write them down since if you multiply those factors, then you get a part of the polynomial. But if we look at the polynomial more, we will see that this polynomial has a total of 3 different zeros. The first thing that we want to look at now is the multiplicity of these zeros. What is the multiplicity? First of all, we always want to have the multiplicity on our table. So I put the multiplicity here, but let's find out how we can calculate the multiplicity for a 0. The multiplicity for a 0, we look now right here on this table, and we can see that the 3 different cases, possible ways that the curve crosses the x-axis right here for any kind of curve. So one way is to just cross the line, go upwards like this, or possibly downwards like this. In this case, what we have is just a crossing. So the curve crosses the x-axis. It reminds us a line. The line, remember, that has degree 1. So in this case, the specific 0 that we're working with, we say that it has multiplicity 1. Another way that a curve can give us a 0 is if the curve doesn't really crosses the x-axis, but what it does, it goes to the x-axis and then it bounces back up, or it comes from down from a negative number, it bounces at the x-axis and it goes back down. In this case, what we see is that what creates is a parabola. Now we remember that the parabola has degree 2. And another possible case is that the curve crosses the x-axis, but at the time that it crosses, it creates a strange S, something like a snake moving. In this case, it reminds us nothing else than the curve, than the graph of the x cube, and the degree of the x cube is 3. So basically, we have 3 possible multiplicities, 3 possible degrees that correspond to a 0. So the multiplicity is nothing else than the degree of the factor that corresponds to a specific 0. Now let's look at our polynomial to find the multiplicity for each one of the zeros. For the negative 3, we can see that the line just crosses the x-axis. Since it crosses the x-axis, the multiplicity will be 1. We look at the number negative 2 and we see again that the polynomial, the curve, just crosses the x-axis again, downwards, but it crosses it. So the multiplicity here will be equal to 1. Again, while at 0 equals to 1, the curve makes a snake. And as we said, snake corresponds to degree 3, so this will be the multiplicity of this factor. Now the multiplicities translate on the polynomial rule as the exponents of those factors. So x plus 3 has exponent 1, x plus 2 has exponent 1, and x minus 1 has exponent 3. So at this point, we can see, first of all, that the degree of this polynomial is 5. But are we done? Not really. One information that we don't have yet is what is the leading coefficient of the polynomial. And when the polynomial is written in a factored form, the leading coefficient is going to be multiplied, a number that is multiplied by each one of the factors of the polynomial. How do we find the a now? Because we have everything else for the polynomial but the a. What we need is to get a point from the polynomial, any point but the x-intercepts. To enter it here, put the x coordinate of that point for all the x's, and put the y coordinate as p of x, and solve for a. And this is what we are going to do right here, with one point that we have that is the easiest point, and this is the y-intercept. So we use the y-intercept in order to solve our polynomial. And we have, since the x for the y-intercept is 0, then this means, and the y-coordinate of the y-intercept is negative 1, then this means that we have negative 1 equals to a times 0 plus 3 to the first, 0 plus 2 to the first, and 0 minus 1 to the third. So we solve that and we have negative 1 is equal to a, 3 plus 0 is 3, 0 plus 2 is 2, so we have 3 times 2 is 6, and negative 1 to the third is negative 1. So the a is multiplied here by negative 6. We solve this for a and we get that a is equal to 1/6. So we found the leading coefficient of our polynomial and we can replace it now in here of the initial polynomial that we have. Instead of a, we write down the leading coefficient that we found, and this leading coefficient is 1 over 6. And this is the final rule of our polynomial. And that's the end of it.